Okay, so in BMAPhysics 3A video, we talked about vectors. And in this video, we're going to start introducing the most important tool for dealing with vectors, and that tool is a thing that you have heard of and you may dread, called trigonometry. Trigonometry. Okay, so basically we're going to start off with right triangles. And then we're going to go from there, but we're going to start off with right triangles. So I'm going to make just a standard, nice right triangle. And we're going to put a little box there, and you should probably know that means that that's a 90-degree angle, and that's what makes that a right triangle. Now, over here, we're going to mark an angle, and we're going to call that theta, and that's a Greek letter. And we're going to define parts of the triangle. We're going to start at whatever angle theta that we have, and we're going to walk up between the two sides that make that angle, and when we get to the side that's opposite that angle, we're going to call that side opposite. Now we're going to find, well, there's another one. I should start off with this one. This big one, opposite the 90, that's got a big name, and I'm sure that you probably know what that big name is. We're going to call that the hypotenuse. Okay. So, you start at the angle, you walk up between the lines that feed into that angle, and when you walk opposite that angle, you get to opposite. On one side of you, one of those lines is the longest side of the triangle, and we're going to call that the hypotenuse, longest side of the right triangle, and the other side that is adjacent to this angle, we're going to call adjacent. Okay. And so we're going to come up with a few different relationships. We're actually going to call this, we're going to use a couple different notations. We're going to call this side A, we're going to call this side B, and we're going to call this side C. And we're going to launch right in with our good old friend, the Pythagorean theorem, which you all know. You can sorry about that. Never mind. Theorem. There we go. Theorem. Okay, while you've been waiting, you can probably figure out what the theorem is. It is a squared plus b squared equals c squared. A squared plus b squared equals c squared, very important. True for right triangles. Now, we've got three proportions that we can talk about. The three proportions that we can talk about are opposite over hypotenuse. We can talk about, I should have left more space here. I gotta make a nice little vertical line here. opposite over hypotenuse. We're going to have adjacent over hypotenuse. And then we're going to have opposite over adjacent. Now there's actually three more that we could have done. We could have done hypotenuse over opposite, we could have done hypotenuse over adjacent, and we could have done adjacent over opposite. And those are going to be important in math class for you, but in physics class we're just going to stick to these three. Now, that ratio of the opposite over the hypotenuse, we're going to give that a name, and we're going to call that sine theta. And so on your calculator, there's a button here that says sine, and if I do like the sine of 30 degrees, it's going to find the ratio of the opposite to the hypotenuse in a right triangle where theta is 30 degrees. We're going to get into example problems later, so don't freak out if you don't understand what's going on. This is an introduction. The adjacent over hypotenuse, can you guess what we're going to call that one? I bet you've seen it already. We're going to call that cosine theta. And then our last but not least, I bet you can figure out what the next one is. Opposite over adjacent, that is going to be tangent theta. Okay. So I don't think I'm going to start an example problem in this one, but in the very next video we're going to do one or two example triangles.